everyone, we're going to evaluate the improper integral or state that it diverges. It's improper because we have infinity as an upper limit. So it's dx divided by x squared plus 5x plus 6. It has this form here, part 1 form. So we're going to use this formula here. All right. Before we get started, I need to rewrite this so we can integrate it. I'm going to use partial fraction decomposition. I know some of you already know how to do this, but I'm going to do it very quickly and factor this out. So this is going to be x plus 2 times x plus 3. Then you set it to, since they're both linear, a divided by x plus 2 plus b times x plus 3. And now we're going to clear the fractions by multiplying each term by x plus 2 times x plus 3. So this is going to give us 1 equals a times x plus 3 plus b times x plus 2. All right, so let's simplify everything. We get 1 equals ax plus 3a plus bx plus 2a. Now, let's go ahead and group our like terms together. Oh, this is b. Now, I'm going to pull out the x and I get a plus b. And then we have, if you want, you could write this as x to the 0 power because that's 1. You have 3a plus 2b. And this equals 1. This would be like 1 times 0, x to the 0 power. We don't have an x, so you could put 0x here if you want. So basically, when you equate these two terms together, when you equate coefficients, you're going to get 0 equals a plus b. And we get, for this, we get 1 equals 3a plus 2b. Now let's go ahead and multiply the first equation by negative 2. So we're going to get 0 equals negative 2a minus 2b. Then we have 1 equals 3a plus 2b. And now let's solve this by elimination. So when you add your terms, you're going to get 1 equals a, because the b's will cancel. So if 1 is a, then we can go back to this equation and set 0 equals 1 plus b. So b is negative 1. All right, so that was as quick as I could go. So your a is 1, so I'm going to substitute this for 1. Your b is negative 1, so I'm going to just write this as negative 1. So from there, this takes the longest part. We're going to go back to use our formula here and go ahead and evaluate the integral. So we're going to get the limit. We're using this formula here again. The limit as b approaches infinity. So now this changes to b. And we're going to have our a part still negative 1 to b. And I'm going to write this as 1 divided by x plus 2 minus 1 divided by x plus 3. It's a lot easier to integrate. So let's go ahead and integrate this. We're going to get the limit as b approaches infinity. This is going to be ln of absolute value of x plus 2 minus ln absolute value of x plus 3. And we're evaluating this from negative 1 to b. I'm going to go ahead and condense my logarithms and using the quotient property and write it as a single log. So basically we have ln of absolute value of x plus 2 divided by x plus 3. And now we're evaluating from negative 1 to b. So let's plug everything in. We're going to get writing too big. So when you apply the limit, I'm going to put it down here. As b approaches negative infinity, we're going to get ln of, let's plug in the b plus 2 divided by b plus 3 minus ln, and when you plug in the negative 1, you're going to get 1 half. So now when you substitute in negative infinity in here, you're going to get negative infinity divided by negative infinity, which is 1. So ln of 1, this is going to go to 0. ln of 1 is 0. So our answer is negative ln of 1 half. We can use our power property for logs and move that up and write this as ln of 1 half to the negative 1 power. And using negative exponents, we can get rid of the negative exponents and write this as ln of 2. So this is your final answer. Thank you. Have a nice day. Bye-bye.